Hello class, let us have another sample problem in our topic work and energy method. Okay, so here's the second example. Two blocks are joined by an inextensible cable as shown in this picture. Inextensible cable, it means that this cable will not be stretched or will not elongate, no, in spite of the weight of these two blocks. If the system is released from rest, determine the velocity of block A after it has moved 2 meters. Assume that the coefficient of friction between block A and the plane is mu sub k equal to 0.25 and that the pulley is weightless and frictionless. Okay, so here's the illustration class. We have block A here weighing 200 kilograms and block B weighing 300 kilograms. Okay, so for our solution, so first we apply the principle of work and energy separately to block A and block B. All right, and then when the two relations are combined, the work of the cable forces cancels, or the work of the cable forces cancel. Solve for the velocity. Okay, so here's our solution. So applying the principle of work and energy separately to block A and B. Okay, so here's the illustration here class. So initially, um, the block A, there is no at this position class at t equal to 0. So the velocity v1 is equal to 0. And since this is heavier, so when this is released, assuming that initially it was fixed here and then released, and it will just move because of the weight of this, which is greater than this 200 kilograms. All right, so the question is what will be the velocity when block A travels 2 meters. So at this point, uh, after t equal to some second after the block A was allowed to move due to the weight of block B. So what will be the velocity at this point? So initially, v1, velocity of block A is equal to 0. After it travels 2 meters, so what will be the velocity? So we call it v sub 2. Okay, so we resolve forces class, we transform it into this diagram. So block A, now considering block A at this moment, so we have the weight, no, for 200 kilograms. So there will be a weight perpendicular to the surface, and we have the normal force acting on this part of the block. Okay, so since there is a friction, so we can say that there is a force opposing the movement of this block A going to the right. So this one is going to the left. And we have FC, no? The force that will pull the block A due to the weight of block B. Okay, so after 2 meters, what will be the speed of block A? All right, so here's the equation. We have the weight. So we have weight from the relationship between weight and mass. No, mass. We have mass equal to weight divided by the acceleration, gravitational acceleration g. So therefore, when you find the weight, you just cross multiply. So therefore, we got weight equal to the product of the mass multiplied by the acceleration. Okay, so since our problem use the unit meter per second, so we use also the gravitational acceleration as in terms of meters per second. So that is equivalent to 9.81 meter per second. So solving for the weight of A, so we got 200 kilograms multiplied by its by the gravitational acceleration. So we get 1962 Newton. Okay, and then we have the relationship between the normal force and the friction along the surface. So they are related to this equation class, that the force uh, of the frictional force of the movement of the block A, that is Fa, is equal to the product of the coefficient of friction, which is mu sub k, uh, multiplied by the normal normal force. Okay, normal force, we call it Na. All right, so we can solve Na by having the summation of vertical forces. So assuming that going up is positive, going down is negative, so we can say that weight of A. Okay, so assuming that we start with n sub A. So n sub A going up, and then weight of A going down, and then equal to 0. So we are summing up forces. We are summing up vertical forces. Summing up vertical forces equal to 0. So we have this equation. So therefore, we can say that from here we can say that n sub A and the normal force is equal to the weight of the block A. Okay. Okay. So this is A class. All right. So that's why we have here force of A. This one, force of A equal to mu sub k times Na. Since Na is equal to WA, so we can have F sub A is equal to mu sub k times WA. So substituting, this is given, and this is also calculated, this one, and we got here F sub A equal to 490 Newton. Okay, so from the basic equation, that the kinetic energy at this point here, T1, plus the work, no, when the block A moves into this direction from 1 to 2, okay, from 1 to 2, from this position to this position, equal to T sub 2. Okay, so that is kinetic energy at this point. And we know that since from this formula kinetic energy, T is equal to 1 half, this is 1 half mv squared, okay, mv squared. So at this point, since the velocity is 0, so velocity here v1, which is 0, so 0, so 0, so this one, at this point the t1 is equal to 0. Okay, so from that formula of the kinetic energy, so therefore we have here t1, which is equal to 0. Then we have fc, no, fc. So we have work, no, work, as mentioned before, work is we use the other letter, not to represent work, so we use u instead of w, because w is used for weight. So work u, this is the product of the force multiplied by the displacement, or fs. Okay, so we have here fc, this is the work done with this force fc multiplied by the displacement, which is 2. So that's why we have here fc times 2 meters, then minus, so this one going to the right positive, then fa going to the left. So in this case, class, we are summing up forces, no, we are summing up forces. So forces going to the right positive, we have this, and then going fa going to the left, we have this, and this is equated to t2. So our t2 is equal to 1 half mv 1 half m sub, this is uh, this is 1 half mv squared. So I think there's a mistake here. So this should be 1 half m. Oh, sorry, this is m sub a. So this is subscript. This means that subscript of m. So m sub a, meaning this is block A. Okay. Okay. Substituting. So m sub a, the mass of A is equal to 200 kilograms. So that's why we have here 100 and v squared. So this is the velocity that we're looking for. Okay. So we have this, and then we can call this as our equation 1. We can call this equation as equation 1. Okay, so we have done for block A. Now, doing the same for block B. So applying the principle of work and energy separately for B. So this time we consider B here. So V1 at this point, before this block moves up or down. It depends, no? If since this is more than or way uh, heavier than the block A, so if no force applied for block A, so it will just go down. Or if force applied to block A going to the left, pulled going to the left. If block B is, sorry, if block A is pulled going to the left, then naturally this block B will go up. Okay? So, but in this scenario class, we have at this position, no? At this position, V1 is equal to 0. Then, meaning this is the initial position of block B, before the blocks are released. So initially V sub 1 is equal to 0. So when it is released, then because it is heavier than block A, so it will pull block A and then it will go down. So this is the second position of block B. So again, as block A travels 2 meters, this also travels 2 meters. Okay, so they're just equal. Right, so we have to find also the velocity v sub 2 at this position. Okay, so applying the same concept, so we have the weight of block B. So again, we use the formula that mass is equal to weight divided by the gravitational acceleration. So to solve for W, so just cross multiply G. So we have weight, the weight of block B is equal to mass of block B multiplied by gravitational acceleration. So this is block B, so we have weight of block B equal to the mass of block B multiplied by the gravitational acceleration. So that's why we have it here. Mass of the block B is 300 kilograms, and the gravitational acceleration is 9.81 meter per second. So we got here 2,940 Newton. Okay, so again from this standard equation, so T1 plus work from 1 to 2 equal to T2. So again, since V1 here is 0, so from the formula T equal to 1 half mv squared. Okay, so 1 half m v squared. So this is a kinetic energy formula. So if this is T1, so this is V1. So since V1 is equal to 0, so 0 multiplied by m multiplied by 1 half. So naturally our T1 is also equal to 0. So that's why we have here our T1 equal to 0. Okay? Then work, no, from work of block 4 because of the weight of the mass of the block B. So 1 to 2, we have FC, no? This is FC. Okay, going to this one, this is the tension, no? Tension of the caused by the weight of this block B. So FC going in this direction. Then assuming this negative going positive, so 0, or it can be positive and this is negative, so the same result will happen, class. Okay, so minus FC because the work is just the product of the displacement and also the force. So Fc times 2 meter plus weight of B, weight of B, which is um, 300, sorry, this is 2,940 Newton multiplied by 2 meters is equal to 1 half m sub B squared. So 1 half and 300, our mass of B is 300 kilograms multiplied by B squared. So you can call this equation as equation 2. And now when you combine equation 1 and 2, uh, what will happen is that the Fc here, because our equation 1 also has Fc, Fc times 2 meters, that is positive. Here we have Fc times 2 meter negative. So when you add equation 1, so when you add equation 1 and 2, meaning equation 1 plus equation 2, so what will happen is that this part here, Fc times 2 meters will become 0 to combine with positive Fc times 2. And then you combine this one, 2 meters multiplied by this with this one here. Okay, so combine them. So adding, and then this one also, when you add, so what will be the result is, okay, so this is the result, guys. Okay, so this is our equation 2. Sorry, this, I think that's our equation 1. Our equation 1 is positive, right? Yes, our equation 1 is positive. Our equation 2 is negative. Yes, it's our equation 2. So when you add 1 and 2, okay, so we have here adding, this is our equation 1, and this is our equation 2. So when you add, have to combine them, so you add, so adding 1, so adding, meaning 1, equation 1 plus equation 2. So equation 1 plus equation 2. So the term that contains Fc will become 0, because when you add this Fc times 2 plus 2 meter times 2 meters, then when you add this one, so this is negative, so this becomes 0. Okay, so in other words, the combination of these two, so this becomes 0. Okay, and then you combine this one, then you combine this, so you have only the unknown here, unknown variable, which is v, the velocity. So when you add, so this becomes 290, then minus with this one, and you add. All right, so we have therefore v is equal to 4.43 meter per second. Okay, so take note that this is Newton meter, meaning 490 Newton meters, so this is in joules. So joules, that is uh, okay. Then we have kilogram meter second, kilogram. Our velocity is meter per second in square, so meter square per second square. So we have joule, Newton in Newton meter, because kilogram meter. So why is it that the joule was eliminated? So because we know that joule is in terms of Newton meter, right? So this is Newton meter. Okay. Then on the right side we have in terms of this will be kilogram. Kilogram. Then we have velocity is meter per second. So you can separate. We have meter per second. Okay. So kilometer. Sorry. Kilogram meter per second. So you separate the meter per second because velocity is meter per second, but this is being squared. Okay, and we just separate them because this one is in terms of uh, Newton meter, right? This is Newton. Kilogram meter. This is Newton meter per second. Okay, so this is Newton. Kilogram meter per second. So that is also Newton. So we have here Newton meter. Okay, so joules here is Newton meter. So you have Newton meter. So this will just cancels out the Newton meter. So you have here left that is velocities in terms of meter per second. Kilogram. Okay, so that's it. And hope you've got the idea, class, on how to solve this problem. Anyway, this is try to work out on the units. Unit in terms of newtons. Okay, so we have Newton meter. No, the unit in Newton meter, which is equivalent to joules, and you have kilogram meter, uh, kilogram meter per second. That is also in Newton. Okay, so Newton meter. Okay, so you have Newton meter. So you have Newton meter cancels out, and then you have what is left is in terms of meter per second. Okay, so that's it for this example. Thank you very much, and hope to see you again in the next video. Bye.